Right. Hello, everybody. Welcome back to week 5 of Intro to Computer Science. I am Apple, back with another lecture, another week. All right, I'm very excited about this week because we will be covering one of my favorite subjects in computer science, and that is data structures. Oh man, data structures, there's so much to dive into about data structures. Uh, we'll try to give you an idea of like what different data structures look like today, how they can be used better, why they're so great, why I love them so much. And yeah, let's just hop into it. Okay, we talk about data structures, structuring data. I mean, what does this all mean? Why does this actually matter? So, in the end, data structures are basically different ways that you're able to organize data in the way that it is stored and how data relates to one and another. The reason why data structures are so important is because data structures, when you organize them differently, depending on your uses, can be drastically more efficient for your own use case. There are certain operations when you're working with a lot of data that are very expensive for the computer to do. And this results in slow programs or lag in video games, or you can also have a lot of problems where you're not looking at the correct data. Sometimes data goes missing, sometimes data needs to be searched through, and different data structures basically gives you that container that is perfect for your project. And data structures also offers you different ways to connect relationships between each another. If you have a data that is, let's say, a book, well, you want to keep the pages in order, so you need data structures that knows about ordering. Okay, one very important note here. I talked about earlier in the previous slide that there are certain data structures that are perfect for your project. Now, keep in mind, this is very important. There is a perfect data structure for anything, and there are hundreds of data structures that works for your project. Don't hyperfixate and focus too much on which data structure is perfect. Focus on the data structure that works first. Remember that it's most important to have a working program than a very, very good program that can always come afterwards. You can always make it better, but working comes first. So, well, I don't know if y'all have seen this meme, but this guy is fitting shapes in different holes, and they all fit into one hole, and it works, and it's fine, and it doesn't have to be efficient. Okay, let's real quickly talk. Oh, right. I'm going to slow down real quick because I feel like I'm getting a little bit too excited here. This is one of my favorite subjects that I'd love to share with everyone. But before I move too far, does the concept of data structures and why it's so important make sense to everyone? Please feel free to raise your hand if you have any questions. But the emphasis that I want to put here are 2 points. Number one, different data structure offers different functionalities and different ways to organize and use your data. Some data structures may work better for your use case than others. But the major disclaimer here is make sure that your program works before making it better. That's the most important thing. It has to work. All right, perfect. Let's move on to list first. Now, we introduced lists very, very briefly during week one. We showed you how to define a list, and it's just a container of a bunch of different types or objects. But today, we're going to delve a little bit deeper into the inner workings of a list. If you're familiar with other programming languages, such as C++ or Java, sometimes these data structures are referred to as arrays. In Python, we call them lists. In C++, sometimes we can even use the word vector. It's different words, but it's all basically the same concept of data structure. Lists are one of our very, very most basic data structures, and you'll likely be using lists for almost anything. Simply put, lists are a container of a bunch of types or objects in an ordered fashion. It's very important to note two things here about lists. The first thing about lists is that you can perform random access. When I talk about random access, I don't mean like, oh, I want a number out of a list and the list gives you a random element. That's not what I mean. What I mean is you can access any one of these numbers within a list or anything you're containing directly. Don't have to step through one by one. And random access, such as looking at the middle of the list or the beginning or the end, is extremely fast. And another very important thing is that lists are sequential, which means every single object inside of a list has an ordering compared to every other object inside of a list. This ordering inside of both Python as well as other languages are called an index. The index refers to the location of where an object is within a list. And I'll show you real quick what that looks like. Now, very important part here. Notice that indexes start at 0. This is very important because indexes don't always start at 0 depending on what programming language you use. If you're using, for example, Lua, Lua starts their indexes at 1. And this really just depends on which programming language you're using, but most modern programming languages will start their index at 0. And we count up one by one. In this case, we have 6 numbers here. That means the index starts from 0 and ends at 5. Let's take a look at what the random access looks like. Inside of a list, if you want to access a part of the list, then you simply refer to its index. So here, I have created list 1 with a bunch of numbers and list 2 with a bunch of letters. For list 1, I want the 0th index. That will give me the very first element. For list 2, I'm printing index 3. Index 3, if you remember, refers to the 4th element. So in the case of a list that has only 4 items, we are referring to the last element. For this first print statement, we're going to print 1. Second print statement, we will print D. All right. There are a couple things that are really, really nice about lists. Lists start at a certain length. Lists start at the length that you define it to be. If you provide an empty list, then the list is empty by default. But it's It's actually very, very easy to add on more things into the list. And it's very fast and easy to expand. For example, here we have a list of names, and we're able to expand two more names to it. Here you can see that we're actually using a list specific function here called append. What append does is that append takes in the input and it adds it to the end of the list. It's very important that you remember that append adds to the end, not the beginning, not the middle, specifically the end. And it will also increase the length of the list. So after having our list being 2 items initially, and we append twice, we now have 4 items. Another thing about list is that it's also very easy and fast to take out items, but only at the end. And I'll explain to you why in a second. For example, here, once we have defeated the evil rich Raza, ruler of Oswak, then we can pop. Pop is a very funny named item function inside of Python. But what pop does is it takes out the very last element of the list and it provides it back to you if you need it. All right. Any questions so far before I move on to why it's slow to remove items from the front of lists? I'm not seeing everyone's avatar, so if you do have a question, feel free to just jump up and down, or Lucia's in chat. So if you have a question and you're on Twitch or Discord, you can just type in your question as well. All right. Lists are great. It sounds like lists do everything, but there are some bad points about lists. And more specifically, if you need these functionalities, then maybe you can look towards something, another data structure that might be faster. The first thing that lists are bad at is searching. For example, if you have a list of names and the list of names are very, very long, we can talk about like millions of names, for example, or even hundreds of millions. Then if you want to search within that list for a specific element, it's going to be slow. The reason why it's going to be slow is because list only remembers what it has and what order it's in. Therefore, you can imagine when you're asking Python to look for something within the list, Python will step through each and every item inside of the list until they find it. So if you're very unlucky and the item is at the very end, Python will actually read through everything within the list until they find it. Another thing that lists are not that good at is if you need to remove items from the list arbitrarily. And by arbitrarily, I mean you're not really sure which order it's in. So, for example, if you remember to the list at the beginning, my name is at the very front, and we have added a bunch of names into the list. Therefore, when we begin to remove items from the list, what Python's going to do, and a lot of other programming languages are going to do, is that we're going to take out the item. In this case, it's my name in the very front. And because we want to keep the same ordering and we can't just leave index 0 being empty, Python is going to step through the list and take every element and move it forward by 1. With only 3 or 4 names, it's not that bad. But when we're talking about, a very large list with potentially hundreds of millions of names, it gets very complicated and slow. So these two things lists are not good at. All right, let's talk about slicing. Slicing is a very, very interesting thing that you can do in Python and some other programming languages. Essentially, slicing in Python means you are taking a part of the list. So imagine you have a huge chunk of a bunch of items, but you only want a part of it. You can use slicing and indexes to refer to which chunks you want. In the example here, we have our inventory of a bunch of items, but I only want indexes 2 to 4. There's one very important thing to remember here about slicing, and that is whether or not these numbers are inclusive or exclusive. When I talk about inclusive or exclusive, what I mean is I say start at 2 and end at 4. Do we actually contain 4 or not? Or we start at 2 and we stop right before 4. In the case of Python, the ending number is not inclusive, which means if we refer to a slice from index 2, which if we remember, indexes start at 0, we can count forward. Knife is 0, sword is 1, shield is 2. We start a shield and we keep going forward until we end right before 4. Shield, potion, broom. Broom is at index 4, but because it's non-inclusive, we don't include it. I see somebody jumping. Do you have a question?
No, I'm just swapping controllers because my knuckle died because Valmedex sucks.
Oh, okay. All right, student in the audience swapping controllers. I hope this makes sense. In most programming languages, the ending number is usually not inclusive. All right, now lists are pretty interesting. In Python, lists can contain pretty much any object. And if you really think about it, lists by itself is also an object. Therefore, you can have a list of a bunch of lists. There are a couple of different applications of having lists of lists. In fact, you can layer as deep as you want. So what I mean by that is you can have list of lists or as far down as you want it to be. A couple of things here that are really nice about lists. Remember that lists are very easily randomly accessible, which means you can jump into the middle of lists or at the beginning or at the end anytime you want very easily. This means a couple of things. By using a two-dimensional list, which is a list of lists, you can use it to represent two-dimensional spaces. So think of like a chessboard, think of like a top-down RPG. This is like the map. Here in the example, we're creating a 2D game board. And as Lucia is fighting an enemy over here, I don't know, I think I'm like running away or something. Oh, that's pretty bad. Maybe I should help her. But yeah, you can see there, we have a representation of a 2D game board. And each of our locations are presented by the index that we're in. So if we need to know where I am, we can access the list twice. This access here looks very similar to how you would normally access a one-dimensional array with just the square brackets. But you can imagine when we step in a single time using board 1, we end up with another list. In fact, we end up with the second row right here. Inside of the second row, I am on the third column, 0, 1, 2, and therefore, in order for us to print me, we have to start from index 1 and end up in index 2 of the list under index 1. Hope that makes sense. A lot of video games use the representation of 2D lists to represent what their world looks like, where they will place enemies, where the player is, etc. Another very important thing here is that 3D lists are also very common in games. For example, I'm sitting here in VR chat. My position is stored with an X, Y, and Z in 3D space. This information can be stored in a big, big list of where everyone is inside the world. So if I move around here, changing my X and Y, and it's changing my position on the board. All right. Now that I've spilled about lists for about 20 or so minutes, does anybody have any questions on lists? What they look like, how they're represented behind the scenes, how they can be used, etc. There are a lot of different examples that can show the power of lists, but for now, when you know what lists are good at and what lists are bad at, you can take a look at the program that you're trying to make. And if the program you're trying to make involves what lists are good at and none of the things that lists are bad at, then lists might be a good choice for you. Okay, we're going to move on to hash maps. If I remember correctly, this is Lucia's favorite data structure. Lucia, please confirm if this is your favorite data structure in the chat. I think it's your favorite data structure. Hash maps are very, very nice. I'll talk a little bit more about hash maps, but in Python, hash maps are sometimes referred to as dictionaries. Dictionaries are also what they can be referred to within other computer programming languages as well, such as C++ and Java. This is a very, very common data structure, and I'll tell you why right now. So, why is it called a hash map? Well, more importantly, it performs some kind of mapping. What is a map? Well, there's two values inside of any hash map. We have keys and we have values. You can think of them as pair matches. So, for example, in lists, we have indexes and we have values, 0 to whatever number, marking their position, and values what is in those indexes. For hash maps, we offer you to control how things are accessed with what data type. So, for example, in here we have a example hash map. In this example hash map, we have a bunch of names mapping to their phone numbers. These names basically map to the phone numbers 1 to 1. The reason that is called a hash map is because it uses a very special algorithm called a hashing algorithm. Hashing algorithms are a little bit complex to explain, but I want to give you all an overall overview of what hashing algorithms do. Essentially, hashing algorithms take any value. So in this case, we have names in the format of strings. And we're able to use a hashing value to map that input into deterministic outputs, usually numbers. The most important part here is deterministic. When you hash any value, if it's the same value, it will always produce the same answer. Why is this important in a hash map? Well, we have keys matching to values. If we have keys matching to values, the keys are hashed and their position on where they're stored is the hashed result. You'll notice that the hash result where we are storing all these values looks a little bit like a list. And that's because under the hood, it is. It's actually a list underneath the hood, but the hashing value allows us to, instead of referring to our values with indexes, we can refer to them as defined keys. So let's take a look at some examples, and maybe this doesn't make sense immediately, but let's take a look at how it can be used, and we can see why this is so powerful. All right, let's take a look up top. Here we define a dictionary of a bunch of birthdays. There's my birthday right there and Lucia's birthday, which is secret. No one can know. So you can see here that by defining a dictionary, we're doing two things. The first thing is we're defining the key, which is a text of names, and we're defining values. And it's very important to know that the text of keys to value mapping is 1 to 1. For every key, there can only be one value. You will never have a conflict of keys and values. Now, that being said, multiple different keys can have the same value, just like how multiple people can have the same birthday. But if you're looking for somebody's birthday and you're using a hash map, it is impossible for you to accidentally get someone else's birthday unless it was filled in wrong in the first place. All right, let's talk about what hash maps are very good at. Hash maps are actually very good at looking up values. When I talk about looking up values, you can think of this as searching or searching through the list for a specific key. Now, note that doing this type of search is very fast only on the keys, but it's still a little bit slow on the values because values are not hashed. Therefore, you have to step through everything one by one. So for example, if I wanted to check if Lucia is in the birthdays list, It's as easy as if Lucia in birthdays in Python. And after you figure out that it's there, accessing it is also very simple and fast. In this case, you can see that we're accessing this pretty much the same way that we would do with a list. Except instead of providing an index, we are actually providing the key, which is the name. Adding things into a dictionary is also very simple and fast. Here, we are adding Blahai to our birthdays list with October 13th. And finally, deleting an entry is also very fast as well, such as removing somebody's birthday from a list. Another very important thing here, unlike lists, hash maps are not ordered. There is no guarantee that inside of our data structure that stores everything, my name comes before Lucia's. Even the order that you're adding stuff in, so let's say we added Bahai last, there's no guarantee that it's actually ordered to be last. The ordering is kind of random. There are ways to step through your dictionary to look at each and every single element that exists within the dictionary. However, just be note that you will never know what element comes before what. Fully randomized. Oops, I clicked the wrong button. All right, give me 1 sec. I'm gonna drink some water. All right, it's very important to drink water. You need to take care of your body. Okay, so that's hash maps. Hopefully you can see why Lucia likes them so much. It's very fast to implement, and if you need to look up anything, you can. Technically speaking, uh, almost anything can be a key, and everything can be a value. The only requirement for items to be a key in a Python dictionary is that the item needs to be hashable. And whether or not a object inside of Python is hashable, I believe most objects that are given to you by default are hashable. But if you're making an object yourself, for example, a class, that might not immediately work. You might have to define some very custom hashing functions there. But that's a bit advanced, and we're going to leave that for another time. Oh, nice. Oblivion says since Python 3.7, order of dictionaries became a certainty. That's very good to know. So I guess in Python, they can be ordered, but if you're using other languages, you're going to have to be very careful and check that yourself. It's not always guaranteed to be in order. And there's still the legacy or dict. Yes. If you need dictionaries and you need ordering, there are actually data structures out there that offers you both. You can have the fast lookups and you can have the ordering. Basically, it just really depends on what you need out of your project. So take a look at what you need to do with the data, and there you can make a decision that fits for you. All right, before I move on to sets, do we have any questions about lists, about dictionaries, etc.? Oh, cool. Okay, let's talk about sets. So you can think of sets as a boiled down dictionary without values to look up. What sets are inside of Python is sets are a collection of unordered items, but all items inside of sets have to be unique. This is the most important thing about sets, is that there's no duplicate whatsoever. The reason that sets don't have duplicates is because of hashing once again. Everything is hashed so that we can perform very quick lookups to see if an item exists inside of a set. Here, we can have a set of animals. In the set of animals, we can add in a cat and a dog. And now our set contains two items. Order is mostly not guaranteed. It really depends on the programming language. If we want to add another cat into the set, after the operation, we will find that our set did not change whatsoever because it only contains non-duplicate or unique data. Now, why would you use a set and what is good about it? Well, sets are very good at remembering what has already been contained or what has already been seen. So, to give you an example, let's say you have a video game and let's say you have a list of quests. Well, within that list of quests, you want certain quests to be non repeatable by the player. In this case, you can very easily use a set to contain the quests that are non repeatable and the player has already completed. So, major game chapters, for example. If the player has already completed certain quests, we can add them into the set. And the next time we try to provide a quest, we can see if a quest that we're trying to provide is already completed or not. That is one example of how how sets can help you order quests. There are only two operations here that you can do, three operations here that you can do with sets. And they're all very fast. The three main operations here are adding and removing, as well as checking to see if an item is contained within a set. There you can see all three being done here with .add, using the in operator, and using remove. All right. I know I talked about only three data structures, but know that the world of data structures is very, very vast. There are so many more data structures out there in the world for you to discover and for you to use in your next project. I've given some data structures here for you to look into if you're interested. Each of them perform something different and they fit a different use case. As a disclaimer, please remember what I said from the very beginning of the lesson, which is don't stress over using the perfect data structure. It's very important for you to have a working program before you have an efficient program. You can always make it more efficient later. We will be sending out all the example code here for all the different data structures along with the worksheet later tomorrow. And just as a super quick once over to see if you're interested in any of these data structures, a queue is a data structure where things come in a queue. So you can think of people lining up, which means whoever gets lined up first comes out first. And whoever gets lined up last will exit the queue last. It does exactly what a queue does. We also have a stack that is almost the opposite of a queue. Instead of a stack, instead of whoever coming in exiting first, it's whoever's most recent comes in and exits first. An example of how you can use a stack is you can use it as like a prioritized to-do list. When you think of something that's very important and you're like, oh, I have to get this done right now, you can add that to the stack. That item gets put on top so that the next time you look at what's my most recent task, the stack has it. For trees, there are a lot of different trees to look into. More specifically, wait. Yes. Oblivion makes a good point here. Gaining intuition for a specific data structure by using it everywhere first is definitely recommended. The best way to learn how a data structure works and how it can work for your program is by simply using it. Just if you're not sure if a certain data structure will be good for your program or would even work for what you're trying to achieve, then simply just use it. Use it and see if it works for your work case. Some data structures might not even work for certain things that you want to do. But knowing what the data structure does, knowing why that data structure is good at certain things can help you make these type of decisions. All right, that was a lot of information. That was a lot of information. I know I just talked a lot about lists, sets, hash maps, etc., and a lot of different data structures that many of us maybe have never heard of. It's a lot of data and a lot of information to digest, and I completely understand that. I will open the floor for any questions, but while you think of the question, do note this. There are a lot of data structures out there that might be better than the one that you're currently using. If you're running into a performance limitation, then maybe it's time to look into data structures. And you can look up which data structures you should use based on the properties of what you're trying to do. So instead of moving forwards and being like, is this data structure good for my program? you can ask yourself, these are the things I need out of a data structure. Is there a data structure that fits what I need? So let's do an exercise real quick. I'll give you all some ideas of what I want out of a data structure. And maybe the students in the audience can let me know which data structure out of the three we just learned would fit best. All right, let me think. Okay, so I'm making a game and I want to have a shop. Inside of the shop, I have a lot of items. I have hundreds of items that I want to sell, and each of these items have a different price. What do people think might be good to fit here as the data structure and why? Okay, I see Aurora raising her hand. Go.
Uh, s- uh, uh, Either a hash map or a list. I'd say that the hash map would be good if there's a way to see what each of the items there are, other than the list itself. Because then I understand that would be a bit more complicated. So maybe a list with all the item names, and then a hash map with the prices in that specific shop, in case shops might have different prices. And I think I've basically said everything I wanted to say now.
Yes, so very good point. We can use different data structures here to represent different parts of the shop. For example, we can use a list to show what items are available to sell within the shop. And other than that, we can use a dictionary to see whether or not we have the inventory for that given item or how much it sells for. So you're absolutely right. There are different data structures that we can use here to represent the shop. And maybe sometimes it may be okay to use multiple data structures as well. All right, good answer. Let's try something else. Okay, so I am checking in people into a very exclusive club. And inside of this very exclusive club, I have a list of VIP names. And I need to make sure that the VIPs all get in and someone behind them isn't trying to pretend to be a VIP if they have already entered. Does anyone have an idea of what data structure can help me here? Oh, I think I saw someone jump here.
Um, that would likely be a set, since you'd only really need to store one of one person, and you could add as many as you want.
Yes. So Oblivion here said we can probably use a set. And that would be correct. For sets, remember that sets are specifically storing non repeated, unique values, unordered as much as we can. And for this VIP list, I can use the set to see who has entered and make sure that only one VIP has entered at once and somebody's not trying to pretend to be the other person. So I can check this list to see who's entered and make sure that one of them is in at any given time. All right, so hopefully these exercises are helping a little bit into seeing why data structures might be very useful in your next program. Of course, you can just use lists for almost everything that you need in Python, and that'll be okay. Remember that a working solution is always better than a non-working solution. So get it to work first. All right. Any questions? I'm gonna give it some time. Do we have questions on Twitch? Roy, do we have questions on Twitch?
I have
All
a
right, cool.
question.
Yes, question here. Go.
Can you hold a list within a dictionary? Like, to a specific key, there's a dictionary, not a single value or string.
All right. The question was, can you have a list inside of a dictionary? Do you mean having lists as values? Or do you mean using lists as keys?
As values.
So, for a Python dictionary, pretty much any object can be used as a value. So you can have keys mapping to lists. You can have keys mapping to your own personal self-defined classes, any type. You can even have dictionaries mapping to more dictionaries. And that is totally allowed in Python and in most languages. All right. I'm gonna give maybe 30-ish more seconds. While I wait, I will tell everyone about this week's workshop. So, going through last week's workshop, for those of you that have taken a look at the workshop and tried your hands a little bit at it, you have probably noticed that we're starting to implement certain parts of a text-based adventure game. Last week, we have asked you to implement a player and an enemy, and then a simple fight loop between the two so that they can do damage to each other. This will go overall into our bigger workshop. And this week, we will also ask you to use some of the code that you have written in the week before. So make sure you keep everything. All right. Going once. Going twice. And, oh, yes, question over here.
Yeah, what's the benefit to appending a list rather than just editing the list directly?
Yeah, good question. So the question was, what is the benefit to appending to a list, i.e. adding to the end of a list versus editing? Well, instead of benefit, I would say it's a different use case. For appending to the end of the list, you are adding more items into the list. While editing a list, you're keeping the number of items the same, but you're sacrificing one of the existing items to change it to another item. So I would say it strongly depends on what you want from your program. If appending to the end of the list and making that list longer makes more sense for you, then you would want to append. Otherwise, if editing a list makes more sense for what you're looking for, then you would go ahead and do the edit. Hope that makes sense. Yeah, great question. Thanks for asking. Okay, I'm going to end it there. Thanks so much, everyone. Of course, as always, Lucy and I will be available in the Discord chat to answer any of your questions if you think of any while you're coding. Good luck coding out there, and hopefully we'll see you in this week's workshop on Friday.